Hello, everyone who's just joining. Welcome. Let's make a start on time. So tonight is our second webinar in the series. And the focus today is to build or help you build a well-sequenced curriculum, which sounds fairly straightforward, but as you'll see, it's probably not and requires a lot more design than perhaps some schemes assume. So I'm Tony, and I run Mastery Science, having spent about 2.5 decades with curriculum design development. And my colleague Gemma, do you want to say hello?
Hello, everyone. I'm Gemma. I've been doing curriculum design for about 13 years, and before that I was a teacher.
A newbie. Right.
Yeah.
So, welcome. And if you have just joined, then we are about to start our second webinar. This is what we're going to cover. So a bit of rationale. What's the difference between what's often a collection of topics, according to Ofsted, and certainly we agree with that, versus a well-sequenced curriculum? We would say that because we've spent years trying to sequence and structure and break down the curriculum and how to deliver it in a way that makes most sense and helps students learn best. If it was that easy, we wouldn't be in a job. So how to do it? We've kind of extracted the main steps from the process that we go through, and we're going to share those with you with a real example from Year 7, and hope that that will help you think more systematically about how you can do something to transform topics that you have that aren't well sequenced. I hope that will be a valuable agenda. You've got a chat where you can ask us questions, make comments as we go through. We'll stop at a couple of points, and you can also open your microphone and speak if you'd like. So this is the first section. What do we mean by making novices into experts? We hear a lot about novices and how we can't teach them too much too quickly. But remember, they're not going to be novices forever. If we don't make them more into experts, we haven't really done our job. If they stay needing to be, overly scaffolded and spoon-fed for 5 years, then whatever we've done hasn't worked very well. So we have to be a bit ambitious about what students are capable of. Oops. So here is the challenge. I like to start with a question because this is really what you're training or educating students to be able to do. Have a look at this question, and I want you to think about what conceptual understanding they need. When you've thought it through, write something in the chat. Okay, let's see if we agree on what students need to understand. Please do feel free to write. Okay, so we need to know the equation and how to apply it. That's true. Is there more to it than that? Is it just about the mathematical use of the equation? And now I have a comment about there are different types of energy. It can be lost Okay, so there are various things that we need to understand about energy. I hope you can see that this is very challenging because you actually need to understand three different concepts here. One of them is clearly about energy and kinetic energy in particular and what it depends on. And then secondly, of course, you need to know something about density because you're going to have to work out the mass of the air or water that's going through per second, and to think through density, mass, and volume. So you need a concept of density. And thirdly, you need to know something about energy resources to know the advantages and disadvantages of each type. So that's three different concepts, and you've got to be able to juggle those and know what's going on with all the data in that table and what it means. So I think that's actually very challenging. And I think it goes beyond knowing the equation, because really what we're talking about is getting a feel for quantities like, you know, the volume and the mass and the speed. And this is actually a kind of qualitative understanding of energy, that it has, kinetic energy has two factors that influence it. One related to the mass, how much stuff is moving, and another one which is related to how fast it moves. And it's not enough just to know an equation and kind of just plug numbers in. You're going to be more likely to make sense of that text if you have a feel for what kinetic energy depends on. So that's really a tough order. And our point here is, if you're going to get to that level of understanding that enables you to do that question without being overloaded with all the information, then this is a 5-year plan. And you'll see what we think about how to do that soon. It isn't just teaching equation in Key Stage 4. It isn't just being able to remember a few energy stores. This is not going to cut it. And this is the idea of expert knowledge. Have a look at the quote from Ofsted. What is it that distinguishes an expert from a novice? So if you've been to any of our previous webinars, you'll know we've banged on about this for years, that it's not just about the amount of knowledge, which is obviously a current fashion, more is better. It's not that, it's the way it's organized. It's structured into a different kind of mental map or schema, whatever you want to call it. And that's what makes it easier for an expert to access the knowledge when they need it to solve problems. And you can imagine it looks a bit like a library collection in a library of books that are catalogued or indexed rather than a mess. This is an expert organization of memory. And at the top, there's a kind of general category, and it breaks down into more specific ones. And that's roughly, for instance, in physics, how you would think about energy or force. You'd have a general concept, and then you'd have more specific ones, and then it would link to all kinds of other ideas. But what usually students have, even by the end of Key Stage 4, is a collection of knowledge, but it isn't well organized. It's sort of disconnected, or it's just, you know, a mess. And that means that it's hard to access the right piece of information when you need it. Now, what we're going to argue is that depending on the way your curriculum is organized and how your topic is sequenced, then it either leads to the expert-like organized knowledge, or, unfortunately, the disconnected novice-like knowledge. So Gemma's going to explain how a typical scheme tends to look.
Okay. So the challenge here, as Tony says, is all about creating expertise. So most schemes we think don't rise to that challenge. So if we have a look, we go on to the next slide. Okay, so Ofsted here confirmed that that's common. So have a quick read of that quote. So most schemes are just a collection of topics introduced in no particular order. So if we go on to the next slide. So this might be a familiar scheme to you. So this scheme comes with a textbook and the lessons are planned around the textbook. So the information I'm going to show you here from the textbook is a fair reflection of what's in the lesson plans. And this is the first lesson on energy. So it's a good start, really. We've got concrete experiences of energy here. We get energy from food and we use it for activities. So that's fine. But what I would expect to see in the next lesson is that students are learning more of a theoretical model of energy, and they can use that to explain more complex ideas. So let's have a look at the next lesson. So basically this is one lesson then on energy before we moving on to something else. And we've got a lot of content here. And as I said before, the order of what's in the textbook is basically the order of the lesson. So if we have a look, we're starting with energy conservation. And we've no idea about actually what energy is. That's quite a difficult concept to understand first off. Then we're moving on to energy stores. So this is arbitrary knowledge, really. We're just saying that objects store this thing called energy. Still no idea what it is, though. There is an attempt at using an analogy here. So we're attempting to kind of model what energy is to help students understand it. They say energy is like money, but I can't see anywhere where that's expanded to be any use. We've just got a diagram of some money there. Then we're introducing energy transfers. We're saying that there's energy before and after a change, using a camping stove as an example. And then we go on to more about energy transfers, but there's no energy transfer diagrams there. That would explain that better. It's just more text to read through. And then we go on to wasted energy. So we've got one lesson on energy stores, transfers, and wasted energy. And that's a lot of information for that one lesson. Plus, I don't think it's in a logical learning progression. We're not seeing simple ideas and then being built on by more complex ideas. We're not seeing students being able to build up that complex schema. Should we look on the next slide? So is energy well sequenced? Well, to add to the issues with the textbook, energy is not taught in this scheme until the end of year 8. Which seems quite late to me. So how do students grasp a deep understanding of all those other topics without the understanding of the basics of energy to build on? And next slide. So if this approach is used, then this is going to be the likely consequence. Disorganized knowledge, pupils aren't going to be able to develop that conceptual framework. Back to Tony.
Thank you. So, okay, we've set up something that we think is obviously not well sequenced and hasn't got much thought about how to introduce the ideas and how they would develop. Energy is a good example because it's really difficult, but that's why it requires a lot more thought. And so here is our attempt to sequence it in a rather better way. So we start thinking at the 5-year level, right? So when we did our blueprint, if you like, evolution of the Key Stage 3 syllabus, which we also designed, we started off with 3 energy ideas because energy is too vague if you leave it as just one. So the first idea is energy is conserved, but notice that it's a big idea. It isn't just something that you can put into a paragraph and tell people on a PowerPoint slide. That's useless. It's an idea that you have to gradually build. So how do we do it? Well, in year 7, because we need it so often, we start it in year 7. We go through 3 different concepts. Heat, which is, of course, something very familiar to students, so it's a good place to start. Then the idea that energy transfer is what's behind everything that happens. And then thirdly, wasted energy. But they're separate concepts. There's certainly not taught in the same lesson. And once we've done those in year 7, notice how energy then reappears quite often, in fact, every year in the plan. And that way, of course, revisiting it in different guises is more likely to connect students' understanding to different phenomena. Looking at it more vertically, so if we're doing energy in 3 different contexts in year 7, you can see how that helps you later to build up ideas about thermal transfer in year 9, and then finally in year 11, kinetic and potential energy and work done. But to answer that GCSE question, of course, which is really hard, we've been doing energy many times. And when we teach in year 7, we're going to do it in a deep way. We're not going to do superficial lists of energy stores. We're going to try and give them a model, because the model is something that they can keep applying whenever they meet energy, and it's actually useful. So now we zoom in to the actual concept of energy transfer, which Gemma's going to show you how we put together. What we're arguing is, because it's a difficult idea, and because to build ideas in the way Ofsted recommends, you're building on whatever students know step by step in small chunks, but you have to get to an ambitious level where they can apply the idea like an expert, which requires the organized knowledge. It's probably not going to work if you just kind of push together a few activities or put together a few paragraphs as in that textbook. It needs a more systematic plan. So this is why we have 3 different stages, each with a different function to build the organization as we go through. So the functions are, and you're going to see these in Gemma's section in a minute. First one, which demands quite a bit of time, is what we call activate. And that's because students have knowledge. It might be informal knowledge about energy. We use these ideas a lot, but we want to make sure they have something, to build on, some prerequisite ideas. And if they have the wrong ideas, or if they have gaps in their experiences, then we want to put those right before we start talking about, the difficult stuff, energy stores, transfers, and a model of conservation. That investment is well spent. The main stage, acquire, if you were with us last week, you will see that we've got these 3 different dimensions. One-dimensional content, just the content understanding, is not enough, as we argued last week, to do an apply or analyze question. This requires an understanding of how to think scientifically. And again, if the students are going to think for themselves, we're going to have to give them the opportunity to take part in the thinking process, not just spoon feed them with content, and develop critical thinking and self-regulation. These are 21st century learning skills. So there's quite a lot to do in that acquire stage. It's not going to happen fast. It needs to be spread out over several lessons, and we have to think through the sequence, as you'll see. And then finally, to go further than just, the camping stove or whatever the concept you presented in the first acquire lesson is, we want to generalize their understanding across different situations. And this is called kind of abstracting, what is it about these situations that's in common? What do we really get as a model of energy that we can use, whatever the context is? And to apply also requires a particular strategy for solving problems, like the one in the GCSE question. We have to first get the information. We have to think what's relevant. We have to do a kind of knowledge dump of what we know about this, and then plan how we're going to put together our answer. And without knowing those strategies, again, it's unlikely you'll be able to, think through a difficult question. So here we have a kind of specification for our learning progression. It's in 3 main stages, and we have requirements for each stage, and that allows us to plan a better sequence of lessons. And now I'm going to hand over to Gemma.
Okay, I'm just going to share my screen with you this time. Okay, so I'm going to be showing you how you can design these activate, acquire and apply stages. So again, we're using this thing called backwards design. And if you were at the webinar last week, then we introduced what this means. So it's what we're aiming towards is being able to answer those GCSE style questions. So first of all, what we actually have to do is work towards that to design those learning stages. So here's the steps that we used. So I'm going to go through each of these steps one by one. So the first step then is to clarify the learning gaps. So at GCSE now, I've got the Key Stage 4 statement about kinetic energy from AQA. They need that quantitative understanding of energy stores. So they've got to use a formula to calculate energy for gravitational potential, stretch, string, and a kinetic. So we decided then, rather than just leave that until GCSE, to introduce this idea very lightly at Key Stage 3. So there's the Key Stage 3 statement from Blueprint. We're saying that the energy of a moving object depends on its mass and its speed. Now, if you don't introduce that, you're just saying kinetic storage is just a useless fact, really. You know, moving objects have this kinetic store, but we don't really understand what that is. So instead, we're going to give them this model, and we're going to say kinetic store is a property that depends on mass and speed, and they're going to get to experience that themselves. So energy is a topic that many students find very difficult. So let's have a unpick why that is then. So it's theoretical. It's not observable by your senses, and it's not very similar to what they've already know coming in from primary school. And the second thing is it involves calculations, which seem very abstract to many students. And you might find with your own students, when you get to GCSE, they find it very difficult to use the formulae for energy because a lot of the time they don't understand the relationship between those variables. Thirdly, energy comes up and it can be used to explain in many different situations. So students need to be able to spot when they're going to have to use energy to explain something in an exam question and apply that knowledge to answer the question. And then finally, there's many misconceptions that students can pick up that will need to be corrected. If they're not, that can be a hindrance to learning new knowledge as well. And a famous one is there are different types of energy, which we try to correct. And also students are going to come in, when you learn this topic in Year 7 about energy, they're going to have informal learning about energy. Now, usually we'll understand that you get energy from food. They might use that informally to say, oh, this object's got lots of energy, or I'm running out of energy, my phone is out of energy. They might have been taught some things about energy in primary school, although it's not included as a concept in the national curriculum. So more often than not, they wouldn't have learnt anything. So you can now see the teaching challenge. So if we use this metaphor, it's like going from the stepping stone of existing understanding over the crocodile waters of misconceptions, trying to avoid those, and to get onto your desired understanding. So step 2 then, this is the first of those stepping stones that we want to take, and this is the activate stage. So Tony's already talked about this, and the purpose of it. Students have come in with those correct prior ideas. We need to build on those, and we're going to correct any misconceptions they've already got. So how would you design then a activate stage? First of all, decide what prior knowledge or skills students actually need to understand this new concept. So we're talking about energy here. What do they actually need to be able to understand that concept? Are there any common misconceptions that they may have coming in about that concept? What knowledge they already have that you want to draw out and activate? Then you're going to write questions or activities that reveal what they already know and help them to build that when they go on to the next stage. And you're going to have to, there's going to be gaps in their knowledge. So you need to write or find material that reteaches those gaps in the knowledge. There's quite a lot to do. And it's not something that you could just do in a very quick starter activity, for example. It's quite a detailed stage that needs to be done. So this is an example of the task that we wrote for energy in our complete mastery materials. So what I did when I wrote this is I thought about what knowledge students may already have and what skills they might need going on to the next stage. So again, they know that food is a source of energy and they know we use it for activities. They're going to be doing some calculations later on, so it might be quite nice to do a few very, very simple calculations here. All students will do that check your understanding task on the left. It's very simple, very accessible. And then they will self-assess it, you will tell them the answers, and then they will decide themselves how well they understand that. Some students, if they do well, can go on to the stretch tasks, which are a little bit more complicated. This is when we're going to say, well, do you know anything about actually how energy brings about a change? And do you know of anything about different energy stores? So we're going to see if they've got that knowledge already. The students that don't do too well on the first task, we're going to teach any missing ideas that they might have. And we have slides then to do that. So the step 3 is the acquire stepping stone. So the purpose of this then is to enable students to build that connected framework of knowledge. We're also going to teach or practice some skills, and this is going back to the 3D curriculum, and we're going to make sure we avoid misconceptions. So how do we design that? Well, first of all, you need to decide what understanding you want them to have and break that into lesson-sized chunks. When we design these lessons, we identified the concept type or the schema. So there's principle, concept, model, or procedure, and whatever concept type it is will determine how you teach the lesson. And then design an activity that helps you to build that understanding and make sure that we identify and correct any misconceptions. So let's have a look then. Here's the understandings from Blueprint for energy transfers. There's 3 main ideas: energy stores, energy transfers, energy conservation, and we have a lesson for each of those. So if we concentrate on energy stores, the schema is a model. So because students, to understand energy, it's an abstract concept, so they need to be taught it using this model so they can make sense of it. And we decided to use these energy bars as our model to teach energy. And then we always have what we call an explore task, which is where students do an activity to help them build that understanding. And we decided to use an experiment here where students experience firsthand that one store, which is the kinetic store, depends on those 2 factors, mass and speed. And they experience how much kinetic energy the ball has by how far it can move the container at the other end of the ramp. So they're actually getting hands-on experience of this. They can see how speed and mass affects the kinetic energy store of the ball. And we're also doing a working scientifically skill of prediction. So we go through how actually they can write a prediction for this experiment, and then they practice themselves by writing those predictions. And here we all, after the students have experienced what affects a kinetic store, we explain this, going back to using that model of the energy bars. So I don't think that's going to work. Okay. So we actually show an animation of the ball and how far it went, so they can check what they did was correct, they got the right results, and then we explain that. And it's important to address misconceptions, so we always show them the wrong idea, so different types of energy, and then we click to correct that to make sure that they do not carry on having these misconceptions. Okay, and the final stepping stone then is apply. So now they've got this understanding of kinetic energy and energy stores in general. Let's see if they can apply. So the purpose of the apply then is to expand the range of situations that students can use that concept to explain. And to help them, we're going to teach them problem-solving strategies. So how did we design these, and how can you design the apply stage? Look through past SATs or GCSE questions. What kind of questions are students having to use that concept in? So like the one Tony showed you earlier. Then use those questions as a worked example to model to the students how to answer them. So how do you answer them? What is your thinking process? And we use this strategy called detect, recall, and solve to do that. And then you can give students your turn examples, so other exam questions that you found or ones that you've made up for them to try to answer using that strategy. So let's have a look at an example. And these examples were taken from our practice book, which has got a range of these questions that you can use. So this is one of the energy ones. So here is the example based on a SATs question. So you show this to the students. Then you will go through these stages, the detect, so what is the question asking me to do? Recall, what do I already know that's going to help me to answer that question? And then you solve the question. So how are you going to use that information to solve it? And then the your turn. So there's an example here. We always have the first one very similar to the worked example. So they can just look back and use the worked example. And then subsequent ones are a bit more challenging. Okay, so that is the end of that. Next steps then, a few things. This is one of the resources. Sorry, yes.
Gemma, I'd like to get the poll going just before
okay, yeah.
do that. Can we ask you all to give us your feedback? In other words, what could you do with what we've just showed you? You should see the poll on your screen. This is our check for understanding, isn't it? Sure. We have some confident people and some not. Okay, we'll keep that open for a minute. And Gemma, you can start explaining Connect.
Yeah, I was just going to talk about our new set of free resources that are available to download from our website. So these are examples of lessons where we've got integrating knowledge and skills into one activity, and they fit nicely into different topics that you may teach. So the link's there if you want to have a look at those. And if you do download them and have a go, then if you share your Connect experience with us, then you may be invited to a conference in Barcelona in July, which is very exciting. And we are going to be sending out emails soon with more information about how you can be involved in that if you're interested.